All right, everybody. Thank you for attending, and welcome to my presentation about building an application security program. Um, so my name is Larry Cox. I am from Pittsburgh, and I've been working in application security for many years since the field really was created. And I've seen a lot of changes, a lot of a lot of evolution in the field. I've worked a lot with very large companies deploying, testing tools, and initially that kind of became into an AppSec type of field in itself. Okay, and so most recently I was working at Cigital and working with the BSIM community in there, building security and maturity model, and we were acquired by a company called Synopys. So I'm just using our logo slides here. I'm not really representing anything, products or anything like that from our company, but so if you see that come up, that's why. Okay. So I have, like I said, have observed what people have been doing in application security in many large firms as well as small firms spanning many different domains, from financials to insurance to embedded systems to just software companies in itself. And what we really find is that there's really no snowflake. There's nothing that's like special in how there's a lot of commonality in what all these companies do. And so what I'm going to do is kind of keep it real high level today. I know you've probably been to a lot of technical talks, and this is going to be like bigger picture type things, organizational things that you can take back and maybe apply to your jobs if you're being asked to start up an application security program. And that's basically what we're going to be covering today. So just an analogy here. Everything now, no matter what business you're in, it's a software business. We used to say, 10 years ago, I used to always lead with saying, like, software is a strategic weapon, and kind of looking at it that way. But now, really what we've seen is, like in the automotive industry is a good analogy, and we're in the same situation today, a very disruptive and transformational era of computing. When Henry Ford rolled out the Model T car, it was 30 years after, about the same amount of time since Mosaic first made the internet generally available to everybody, that it wasn't new. Cars weren't new, but what made it new was that the fact that it was mass produced and created like 15,000 orders right away. So similarly, we're seeing a similar type of transformations, like for example in the automotive industry, where you got cars that are getting 40 software releases a year, right? And so we're seeing that kind of thing happening now. So application security is going to be increasingly a focus in companies. Traditional defenses are going away. Things are moving to the cloud. Things, controls that you had in place one day are blown apart and not there anymore. And we're a lot of times we're finding ourselves, kind of reverting back to bad habits in those cases, right? So I kind of want to point some things out. In spite of all the changes that are going on, agile development processes, CI/CD, things of that nature, very, very, some companies releasing multiple times a day, things like that. These things still stand true. These tenets of software development. You could apply it to any non-functional feature of software. That security is an emergent property. It's just like you don't just bolt on performance at the end of an application, right? You have to kind of think it through, and there's a lot of aspects to it, right? The other thing is that we tend to focus on coding vulnerabilities in AppSec. We really need to start increasingly our focus on getting the designs right up front, picking secure frameworks and things of that nature. So don't forget, bad designs account for 50% of the flaws that we see out there, right? And that's just data. That's just the facts, right? And those are the most expensive ones to fix. So your AppSec initiatives are going to need to get involved with application security up front and get it into a very fluid and frictionless environment. Because no matter how much you test, is what I always say, you can't test yourself to secure software. So it's really you're going to have to really put developers' hats on. You learn to think like developers. work with them and create these more frictionless integrations with application security inside of their SDLCs, whatever processes they're using. How many of the people in this room here have teams that develop software? Okay, quite a few. Okay, all right. Because it also applies to vendor management and other things as well. There's still traditional things that we see as well. We'll touch on that a little bit later on. So what I want to talk today is like, how do you get started? You know, how do you convince somebody to start investing in application security? So that's the first hurdle that we have to overcome. Sometimes it's, you know, you've been asked to do this, but you're not getting adequate funding. So you got to find a strategy to go about that. Then I want to spend most of the time talking about how do we shift the culture and, you know, make that seamless integration with, software development. And then how do we just, you know, what's our first steps? What should we do to get, you know, kickstart our process? All right. Okay, so this is a couple of animations here. All right, so whenever you look at the type of controls that you have inside of application security, you typically have things that occur today, and you'll typically have things that occur late after it's been pushed into production, such as pen tests, right? Then you'll have things that occur a little bit earlier, like, for example, a source code analysis inside the build process, or testing in QA, things of that nature. And then you have preventative measures, and those are the ones that we were talking about, where you like work with them to develop, you know, secure libraries, you know, open source, making sure the open source that's brought in is secure, things of that nature. They're more preventative in nature, as well as especially training and things of that nature. So the way you can think about this, these tenets have been around since I first started, you know, software engineering at Georgia Tech in the 80s. And basically, there's the 110-100 rule, where things are, or at 110, 100, 1,000, 10,000, it goes on. Things are more expensive to fix once it's been put into production, particularly if it's like an embedded device and it's, you know, they have to come out and do a maintenance on it. For it's like a meter, for example, like a guy can come out and replace a meter. Now they can patch them up remotely, but those things are very expensive to fix, right? So what we're seeing today is a shift in the CISOs of thinking away from just thinking about risk. Like it used to be like about what's our risk disposition, but because of these digital transformation initiatives and rapid delivery of applications, you're seeing the CISOs starting to like be, you know, the cultures of the companies are becoming a little more risk accepting, right? They're saying like, well, you know, we have to move fast because Amazon's, you know, doing this, and our customers expect us to do the same thing, you know, that Amazon's doing, right? You know, that's becoming an expectation. So what happens is, you know, risk becomes a little more, you know, acceptable in a lot of these organizations. Less so in financial services, because you still have a lot of federal government, you know, regulations and things of that nature and around that. But in others, maybe not so much. So what we're seeing is that in order to justify the investment in these things, is that we know that they do want to get them fixed, right? So we have to look at it from a software economics perspective, right? And basically investing more aggressively in the early SDLC work, right? It's really a balance. You're still going to do your pen test, but you also need to do things earlier in the process. And basically, well, we know this because we interview a lot of CISOs in my job. We talk to a lot of people as part of these building security in maturity model BSIM studies, right? And so we've collected this information, and this is a trend that is occurring. It's something that we actually observe across you know, many companies. And so one of the things you can start saying, like, okay, we're pen test. So you're starting your program. You're saying we're doing all this pen testing, and we're finding these list of, you know, high and critical vulnerabilities, mediums, and whatever that you find as a result of a pen test. And then you throw it back over the wall to the development team, and, you know, they get around to fixing them, right? So in the worst case scenario. But you may have a policy in place that requires them to fix them right away. But meanwhile, you've got to either roll back changes in production and things like that. It makes it much more expensive. So what we want to do is start engaging with the development teams earlier in the process so they get it right to begin with. And that is some real data around here. Actually, I'm going to have to email these slides, I think, for you as well. What car makers can teach enterprises. This is a real study from a very large insurance company, and whom we work with. And this is the real data that they've tracked, is that cost of defect, this is called them defects because they differentiate between a vulnerability and a defect, in different phases of development for a real company. So once it was in this, you notice the phases here kind of tailored, maintained. That's their terms of production. It's 14,000. But if we were to be able to codify those things in terms of requirements, so that the developers know what to code with in the beginning, right? It was $139 because they just fix it in their IDE. Okay, and there are tools. We'll talk a little about tools that allow you to do that. So what that translated was that their legacy program, the way they were doing it, to fix things the way they had been going down the traditional paths, it would have been a $20 million, difference compared to the way they're doing it today. All right, so there's roughly a $21 million cost savings of implementing this program. Now, this is a very big company, right? So, but that's a lot of money. That goes a long ways. It communicates very effectively to the board level and people of that nature. They get this. Doing things right the first time makes a lot more sense than, putting the electrical wiring in after you put the drywall in your house, for example. You don't want to do that. So that's one tip you can take those numbers and you can look at them and use your own thinking about how you want to do this. Look at your average loaded cost per developer, per tester, things like that, and you can come up with your own metrics. It is possible to do that. But to do it, you need to at least have started doing some testing that's post-production, like pen testing. All right, to shift the culture, basically you have two levers you can play with when you're dealing with a culture. One is around enablement, getting people equipped to do the right thing, to code properly. So that's going to involve investing in the people, getting people some good tooling that allows them to code in a way that they can prevent defects from occurring in the first place, right? And also integrating smoothly with the SDLC early in the process, right? So that we'll talk about that in some detail a little bit later. The other way is you reduce the friction. Okay, so you don't want development teams to continue to think about like, oh, it's security. It's those people. It's we. We're a team. DevSecOps. That's the changing culture there, right? I'm sure you've heard of that. So I'm not going to go into that too much, but basically you need to have a way, and we're talking about a way of getting some security expertise embedded into the teams. Okay. And improving by doing so, you improve the collaboration amongst the dev and SecOps team. And ops is becoming a bigger and bigger thing as we move to cloud as well, because as we have moved to cloud, and particularly as we're moving to platform as a service and infrastructure as a code, you're finding that a lot of the things that were traditionally responsible of an infrastructure team are really shifting more to the AppSec team about like what are the policies around virtual firewalls and things of that nature that typically are pretty messed up if you start looking at an early initiative on that. And so that all of a sudden becomes the responsibility of the AppSec team. So ops is going to be a more and more important area to focus in on. That's the wrong way. All right, so here's an example of what I mean by investing in people. So you need to have role-based training, and this is an example of some role-based training curriculum. But basically, you have different roles: your mobile developers, your QA people, your architects, however you decide to split the roles up, but it has to be very specific to the roles. There's probably some foundational classes that everybody takes, but then as they get into a little more intermediate and advanced classes, they're like language specific. You don't want, like they'll be about Java versus PHP or whatever languages you might be dealing with, right? Mobile, of course, right? Things of that nature. So you basically you want to create a role-based curriculum, and you want to roll it out in a way that's like, here's the foundational things, here's the intermediate things that we want people to do, and then as you progress, maybe a year later, you start layering in some advanced activities, right? So when I say role-based training, what the takeaway here is like the roles are very granular, right? And also there's some tiering to the training. There's a lot of companies that provide this now. And ideally what you want this to be is kind of like bite-sized training as well, right? And I'll talk about in a little bit. Also, the training can also be integrated inside the whatever IDEs they might be using. A lot of times there's like you have a vulnerability that's been found, and they can click on that, and it'll spin up a little training, a 1-minute training module on how to prevent, SQL injection, which unfortunately is still very prevalent 10 years after we started tracking it. All right, so the other one is how do you get, so you got the training. So we know training alone, it's good, but a lot of times it doesn't stick real well. People revert back to bad habits if there's nothing around it. So you got to embed yourself. Remember, you got to reduce that friction by getting embedded inside of the development process. So all the firms that we refer to in the BSIM, currently 120 different firms in the study right now, all of them have an AppSec team, and most of them have a good many of them have what's called a satellite program or a community of excellence. It's something like that. It's a well-run, structured program, because there's probably going to be like a couple of you in an AppSec team, or maybe 5 or 6. There's not a lot. Then you got to, how do you scale that, right? So what you do is you begin recruiting people that are in the development teams that have a natural interest for security. So you can screen them. You can use Secure Code Warrior or things like that I've used in the past to kind of figure out who's going to be reach your benchmark that you need, someone that can do this. So it's typically one of the better developers. It's not going to, you don't want someone that's like a real green doing this. It's got to be someone that has someone that has some credibility, with the other developers, right? So someone a little more senior. All right, that is interested in doing security development as well. And so once you recruit them, then what you can do is you can organize a champions program or a satellite. And sometimes people call them mavens. There's a lot of different terms that they have with this, but it's the same idea. So it's basically a team of people that are centrally run by an AppSec team, but distributed into the development. They're typically developers. They're part of the development team. But they could be QA people. They could be architects. Different roles. Don't get me wrong there. Okay. Then what you'll do is you'll want to structure your program, because you can't do everything all at once. You'll create some sort of banding for people. At first, you may not have any because it'll be a little more informal. But as it starts getting traction, you'll run say like, I need someone that's going to. You can use belts, you can use metals, bronze, different ideas like, bronze medal, silver medal, gold medal. This company here, this example here uses belting, for example. So that's actually kind of taboo in a lot of companies because it's the Six Sigma thing. So a lot of people aren't into that. So you can use whatever words you want. But the principle is that you start them off and you say, okay. We've purchased some static analysis tool. Well, let's get them knowing how to run the tool, do some triage on the results and things like that. This is real basic stuff, right? Just get them going with that. And what we're doing is we're asking them to spend maybe, a couple hours a week initially on this type of work, right? As they move up into like the green belt here, now we're asking them to do a little bit more. We're going to start asking them to do maybe we want you to do a little bit of design review and threat modeling, right, that we might be doing in the AppSec team. So a threat model is a very good way of understanding what the security requirements are for a new application or an existing application. In the case of an existing one, it's a very good way of understanding where there might be some potentially serious design flaws and identifying and resolving those. So you should always do threat modeling on the apps, on your most critical applications, right? You ideally want to do it on all of them, of course, but we'll talk about risk ranking the portfolio in a second here. But as we move up into the brown belts, then what we'll do is maybe we'll add some other capabilities for them. Maybe you've purchased some other tools, or you want them to write custom rules. There's plenty of work to do that are in more advanced areas of testing and things like that they can do. And in this case, they had a black belt, which actually be people that serve on various boards and create reusable IP in Burp Suite, things of that nature, for example. All right. So you have so the takeaway on the champions is that they're developers or people embedded in the teams. You need to set expectations that they're going to need a certain amount of time dedicated towards being advocates of application security amongst the developers, right? So whatever time that is. Sometimes it can be as little as like a couple hours a week. Some companies have actually said we're going to actually make them almost full-time, because they have really big development. They cover a big development team, right? I prefer to have them actually be developers and spend maybe 8 hours a week around the application security topics, like helping developers fix, things that the tool found, or, explaining things why it's not a false positive, that they need to fix it. Spend doing that type of discussion, but still be engaged with development, because they've got more skin in the game then. They're not, if you got someone that's full time, all of a sudden you're kind of right back to where you started, where you're like, oh, it's that guy. He's not really contributing code to the code base, right? So that's my personal preference. I've seen it done both ways. I feel that it's more effective, though, as being part of the development teams. And then you can tier it. And it's not, I think a lot of this is focused on training here. Like, this is training that we identified for them, but you're going to have activities. So you should basically define roles and activities for all the champions. You typically do that like in a charter document or something along those lines. So how do the way that we have become getting application security embedded inside the SDLCs is, I've often referred to it in the past as tool-directed governance. Okay, now I've heard the latest term is software-defined governance lifecycle. Okay, so basically what we're doing here is we're taking your policies and things of that nature, and we're implementing it inside a tool chain. Okay, so this is a kind of a little more advanced way of doing things. It's something that you'll grow into. So I'm going to kind of go through it step by step, and what you'll end up doing is you're going to have to pick, like, where do you want to start, and we'll talk about that a little bit. But so typically you start in an agile process. You have your backlog. So it's important to have policies and also a threat model that can help feed that backlog. Okay. And the product backlogs should contain your stories, but it also should contain non-functional requirements, NFRs, right? So what you want to do is translate your policies and coding standards and things that you want people to do into non-functional requirements, right? This is the single biggest thing you can do, because now the developers know what they have to write from the very beginning, right? So, they're not going to be getting at the end of the project and saying, like, well, I didn't know we were supposed to use, 6 inches, a foot of encryption instead of 1 inch of encryption or something like that, right? So they'll know all that stuff up front. So once they're working inside the IDE, there's a lot of the tools now have ability to do some lightweight static analysis inside the IDE. So it's almost like a spell checker. You know, taps you on the shoulder, says, don't do that. Developers, and include myself in this group, is we hate seeing the little red check mark in the IDE saying, all right, something appear yellow, we've got to fix it. It's like an OCD thing. So that's really good. And then the training. Remember, I mentioned all the training we do, but you can also have that just in time training, like it's saying, okay, it's cross-site scripting. So how do I fix this? How to do input sanitization, for example. What's a good thing? So those are the type of things that you can put in there. So very valuable, very good place to start right here is training and getting it in the IDEs. All right. So the next thing you'll do is the developer is going to want to commit their code. Okay, so now it gets into a little more complicated static analysis tool smithing. So anybody who here uses a static analysis tool in the build process? Anybody? A few of you? Okay, all right. Yeah, so there's lots of tools out there. There's open source tools that are there, but they tend to generate a lot of noise, and they're pretty expensive, but so when you do deploy them, you want to really make the best of them, right? So one of the things we're seeing people do is initially, several years ago, the static analysis tools were run by a static analysis tool team, and every now and then you'd get the code and you run the static analysis on it, and you give the results back to the developers. A little bit like the pen testing mentality, All right, what we're trying to do now is we're trying to get that even before they commit their code, we can do an incremental scan on the code, right, and prevent them from committing the code. So it breaks it at that point there. You can't commit it back into the main line because you've got a little deeper scan than what you would get in the IDE, in other words. But still, this scan has to complete like in 10, 15 seconds, right? It's not something that can take, like a static analysis can take 24 hours or so to fully run across the whole code base. All right. So other things they can look at is at this point is when they're doing some unit testing. So there's some tools called. Have anybody familiar with IAST terminology? Interactive Application Security Testing. So it's a new technology. There's a couple of basically two companies that are the leaders in that. But it's a very effective tool because it kind of combines the outside in of a black box text of like a DAS dynamic scan with the inside out of a static scan, right? So what happens is that in some of them you get very little false positives as a result. Very, very good results out of this. So it eliminates the friction around triage, right? So you can run some of that in this. Typically, it's run once it's in the fully built app in QA. But I like to got some clients starting to do it here. If it passes that piece, then you're going into the build process. Okay. So when you're doing a build, now you've got a working application. You can do some risk-based testing based on what your non-functional requirements are and looking at those, right? You can do static analysis. You can do software composition analysis here, which is looking at the open source and the feeds of open source in here and see if they're using both either viral licenses, for example, is really bad in some cases, but also vulnerable, well-known vulnerabilities in certain open source libraries, right? You don't want to introduce that as well. So the composition analysis can occur at this point. Then what we'll see is we move on to testing, right? And this is typically where you see the IAST come in, is in the test phase. But you can put it in earlier if you're willing to run it on the developer's desktops. And this is where you have your dynamic scans. But so these scans can take like overnight to run. And so sometimes they don't. If you're running in a continuous delivery type of mode, very few companies are doing this today, right? But people want to do it. It may take too long to run. Okay, so there's strategies around that where you have to. That's where I'm saying companies are willing to accept the risk. They actually go ahead and deploy it, but then you have to have a whole architecture around microservices and things like that. That we're talking about Netflix and companies like that do this type of stuff. So, but that's where the bar is, and that's where we'll be in a few years, right? Everybody's going to be doing the same type of doing the same type of work in a few years. So just letting you know ahead of time. So you can do some pen testing and things of that nature, and then you eventually get back into the deployment. So here's an area where it's emerging now, is where you're wanting to look at the deployment environment as part of the development lifecycle, right? Because if you're going into the cloud, and you can do AWS, there's Amazon has cloud native tools. There's tools like Redshift, things like that inspect your accounts, and it just basically goes through a list of hardening checks and policies for that as well. So that's what used to be deploying into a hardware environment. Data center is becoming part of the AppSec SDLC processes now, right? So we're seeing that emerging as well. And actually, that's actually an area where I'm getting pulled into a lot more as a result of some recent well-published breaches that occurred last year. A lot of companies are asking us about what about our cloud, strategy and things of that nature. So, as a matter of fact, in the recent vSIM version 10 is out. If everybody heard of vSIM? Anybody? A few of you? Yeah. So it's a. I was going to save it for the end, but I'll talk a little bit about it now because I'm making a lot of references to it. The vSIM is a study that's been going on for about 10 years, started by Digital company, that has basically an observational model of what companies are doing. Not like here's what you should do theoretically. It's like here's what people are actually doing, right? And so what happens is it gets revised every year because some things that people did were very common 10 years ago are not common anymore, right? And so they kind of tier it. They call it maturity because the least common things tend to be more mature, but it's basically 3 ranks. Here's your most common activities, your middle number of activities, and the fewest number of things that people do, right? Well, they added some recently, and the past 2 vSIMs are really all around companies starting to do this type of cloud work, right? Because before no one was really doing it. Now we're finding out people are starting to harden it as part of their application security program, cloud security basics, software-defined governance. People are starting to do this. Not a lot of them, but I fully expect when we go do the next year's study, we'll see a lot of these things move from a level 3, which is infrequent, to a level 2, more frequently observed activity. There's a lot of interest in this right now. And then you're eventually in production, and that's where you have red teams, bug bounties, things that you like that you have there. And whatever happens there in production, at that point, once it's deployed, it's got to go back into the backlog, right? It's too late. The sprint's already, they might already have a sprint on their way. There's whole ways of dealing with that. And what I refer to things that aren't inside this is these things that are gold colored here, or out of band activities. All right, so how do you get started? So you define. First of all, you need to create an application security group, an SSG, or software security group, if you wish. And define the roles and responsibilities, the champions, program, things of that nature. Okay. You need to establish a risk, but you need to adapt the process based on what is acceptable in your company in terms of risk. What are you an agile shop? Are you still doing waterfall? Are you doing a little bit of everything? You need to adapt it, and I'll talk a little bit about that. Then you need to phase in some new capabilities. Now, I went over a whole lot of stuff. Obviously, you can't do all these things at once, right? So what we want to see is like a well-balanced, like an inch, an inch deep and a mile wide type of strategy, right? A well-balanced strategy across the different disciplines, from policies to all the way to pen testing, right? And just roll out a few of them initially. Okay, make sure you got policies in place, that they're well communicated, people are trained on them, right? Put some sort of, initially you won't enforce the gates, but you need to identify, where you're going to start holding people accountable. Like, hey, you can't release things into production anymore that has that there's a critical vulnerability because your static tool told you. Initially you're going to inform them, but eventually you're going to enforce these gates. Third-party management. A lot of the companies, you outsource mobile applications to more boutique firms that specialize in that. You have custom software that's developed for you. You need to start bringing in some of these. Ignore what I said about vendor vSIM, but you need to start bringing in some sort of policies, your policies, and making sure that they're doing something similar, right? Holding them to a certain level of accountability, right? Okay, and probably one of the most important things is to get metrics, because that's where, remember those when we talked about the business case earlier, you have to have metrics to report to executives. But make sure the metrics, your CEO is not going to care about how many vulnerabilities were found in a month, right? They're going to care about, like, something that's more tangible, like, hey, our AppSec program is saving us $1 million a month in remediation costs, for example, or something like that. Yeah, so you adapt the process on things. What's the expectation of the business, right, is one. What type of, is it confidential information that you're protecting? What type of assets are you protecting, right? What does an attack surface look like? What is it, is this internet-facing application or versus something that's just on a couple of people's desktops? Okay. What type of technology? Is it, using going to cloud, for example? It might make it a little more risk-oriented. Right, and then of course regulations that dictate a lot of what we do. So based on your risk, you come up with look at your application portfolio, and from a security perspective, your portfolio, you probably have a list of applications in your portfolio of apps. In there, you want to be able to discern whether it is a high, medium, or low, or you can use, some people use a scale from 0 to 100, anything over a 37 gets this treatment. But basically, based on the risk of the application, for example, it's an internet-facing application, then we process credit card information, for example, we move money with it. So it's a high-risk application. So, hey, do we have a champion assigned to that development team? Yep, we got that. We're doing threat models. We're doing all these. So we do everything on those. But then we have other applications, that aren't that important. They have very low risk. But you still want to champion with them, ideally, in this case. And are we doing a little code review on it? We're looking at the open source that we're bringing in, maybe from a licensing perspective too, right? All right. So you do less things. So the process, the takeaway here is the process needs to be adapted based on the risk of the application, right? And we have kind of like this path to maturity where, for instance, you start ad hoc. A lot of companies are down here, big companies. And they're perfectly fine staying there. That's just where that's good enough for them, But a lot of companies that really want to can't afford to lose the trust of the customer. They need to move fast and so forth. They want to get over to this optimized side. And an interesting thing we're seeing is companies now that are just starting to really take on AppSec seriously. Are really kind of just jumping right in the optimized piece. They're jumping right in with this, let's go ahead and start with this process of, getting the champions in place, getting the development tools integrated with the development life cycle, things like that, right? So where you jump in here you don't have to start at the bottom left, is what I'm getting at. You can, depending on your culture and things in your company, you can jump right in and say like, hey, look, we have a Jenkins tool chain. We have, we're an agile shop. We could be a small, unique size of company matters, right? You could be a smaller company. You don't really need a lot of ceremony around, governance and things of that nature. You're not regulated potentially. You might be able to jump right in and get into this, tool-oriented governance model, right? The important thing, though, is to make sure the developers are enabled and their expectations are set properly with them up front. Okay. Oops. Yeah, try the old fashioned. Yeah. So here's an example. I'll just put this together. Some things like, you notice how we got all these practices, all right, and you can phase them. We can phase in some capabilities, balance it across the different practices, right? If you go to bsim.com, you'll find a really good framework for organizing your thinking and thoughts around how you want to group things together and how you want to approach this, right? Okay, so it's phased in, across disciplines, year 1, year 2. And here's a real life case study of an application that of a company that invested. Actually, it was the same company I used the metrics on in the first slide at the beginning. What they invested in, and as you can tell, they put a lot of money into it. But they wanted to become a world-class organization within 3 years. Well, you know what? It cost a lot of money to do that. So now they're very innovative. They got the DevSecOps alignment and things of that nature, right? So a little bit on the BSIM. Again, if you go to bsim.com, you'll see that there's the most recent BSIM 10 studies published there. It's open source. And you'll find data around all these areas. So each of these, the BSIM is structured into these 4 domains. Each of the domains have 3 different practices in it. And then within the practices, there's a number of activities that varies. There's 119 or 120 activities in the BSIM now. No company does them all. Not a single company does them all. I mean, most companies do about a third of them or fourth of them, something around that, right? But those are things that we actually observe people doing, and you can use it as a business, as a management tool to see like how, that makes sense in our company, right? You can go look at it and say, and you'll see like in it, it'll say like, 76 companies are doing this. So it's like a very common one, like coding standards or something like that. And he says we should probably do that too, because it's so common, right? And then you'll see some things that are not common that you say might really apply to what you're doing, though. So it's a good way to look at it if you want to look at a good holistic view of all the things you should consider and like pick a dozen things out of that and say let's go take these things on if you're just getting started. Okay, with that I think that's I talked about this earlier, and yeah, so I'll just I don't have a table here. So give us a few minutes for some Q&A, and so if you want to come up and talk to me or whatever, I'll be here for a few more minutes. I think the big, so I think that, right. There's some other frame. I think the big difference, what I like about it is it's just a study of what people are actually doing as opposed to what someone says they should be doing, right? And it's very broadly scoped too. So it's not just focused in on testing, types of testing and things like that. It goes from like what is legal and compliance, and what is the oath group doing, and so forth. But to me, what makes it valuable is based on real data of what companies are really doing, and you can use that, harvest that data, and base your initiative and your decisions on data, right? As opposed to like, a theory, or like, which is good too, but it's more. This is a little more scientific based. But I view it as a management tool. It just says here's what companies are doing, and there's enough of them in there that it's relevant statistically, right, to do that as well. All right, you guys are all going to go out and start an AppSec program now? Getting ramped up. Yeah. Oh, right. Yeah. Or something like that. Yeah. Yeah. Right. In this deck here, let's see here. Go up here. When I talked about it, maybe animations right here. Okay. This is this one here. So basically, you can use like some metrics. So if you're are you doing testing today? Any at all? Like after product, once in pen test? Yeah. So yeah. And so take a look at what vulnerabilities are done there, and start looking at. Just take a sample of them and say how long did it take for us to get them completed? It has to go through some sort of review process. It's got to be assigned to developers. It's got to be tested. It's got to be re-released. It could be something you have to communicate to clients. Take the whole cost, right? And basically, what you can come up with is some sort of that bar on the right there, right? And then what you can do is you can go and look at this economics of software security, what car makers can teach enterprises, right? Under dark reading, this article here, it'll talk about how you break that down. But basically, you can use some well-known metrics that say, like, okay, this thing is much cheaper to fix if it's done in requirements, right? There's an old study done in the SEI by a guy named Barry Beam, B-O-E-H-M, I think, or B-O-E-H-E-M or something. But it was done in the 70s, and it's kind of waterfall rooted, but it's still very valid. But basically, it just says that things are 10,000 times more expensive to fix in production than if you fix it in a requirements document, right? And you can so you can translate it that way, right? Yeah. It's very helpful to kind of if you're just taking on an AppSec program and you're having a hard time justifying it, to get do pen tests that are deep and on your really get some pen testers and code reviews done on your most critical apps and really break them and find a lot of good stuff. And then you can start using that because those are things that people aren't even aware of, right? And you can say, here's the stuff we're living with today, and we want to quit doing this, right? We want to not do this anymore, because they may or may not want to fix those because you've already been living with it, So, but they probably don't want to keep going down that same path. So here's a way forward.
Haven't looked at the BSIM since BSIM 4.
Yeah.
Back in the day.
Yeah, back in the day.
Have there been additions of, say, manufacturing verticals to the BSIM? And if so, are there good ways of splitting out what has been done, kind of internal enterprise support AppSec versus, this is the AppSec we're doing in the product itself?
Right. There are some manufacturing firms, but there's not enough of them to be segmented off as a vertical. Okay. Unfortunately, you got to get around 15 or so. There aren't that many in there yet. Not yet, anyway. But yeah, some automakers and embedded systems, things like that are in there.
Have you noticed that, do they think of their AppSec program as universally, or do they kind of segment off the groups that do the internal app support for business operations, and then the group that's writing the software for the embedded device or the automobile?
More and more, they're putting them together. Yeah, but in the past, it was definitely. Are you talking about within the company itself? Yeah, right. Yeah, it's funny now because a lot of these companies don't have developers; they have engineers, right? Right, and that write code, right? And it's even worse, right? So you definitely need to tailor things to those environments. Still, champions, all these things still apply. Design flaws. The basic tenets are still there, right? Yeah. Very good. All right, thank you. Good.